Okay, so this is the problem given, right? A continuous stirrer reactor is to be designed for a homogeneous liquid phase reaction. Liquid phase reaction, if it is given, means it is nothing but it is a constant volume reactor, because epsilon A will be equal to 0 whenever it is given. So only for gas phase reactions you need to take into consideration of variable volume reactor for the production of chloroethane, and this is the reaction given, that is HCl plus C2S44 gives rise to C2H5Cl. And in the question it is given that it is a first order reaction with respect to HCl, and with K is equal to given as 0.002 second inverse, with the volumetric flow rate is given as 0.002 meter cube per second, and the feed concentration is given as 1 kilomole per meter cube. So in the first question it is asked to calculate what is the volume of the plug flow reactor required to achieve 90% conversion. And if we use this reaction in a CSTR, what would be the, will it be better or not? We need to justify the answer. Okay, so for that, first I will write the given data solution. So solution is first order, means minus RA is equal to K into CA. Okay, K into CA, and the rate constant K is given as 0.002 second inverse, 0.002 second inverse, and volumetric flow rate mu is given as 0.002 meter cube per second, and concentration Ca0 is given as 1 kilomole per meter cube, 1 kilomole per meter cube. And in the first question it is asked what could be the volume of PFR to get the conversion as 90%. So now I will write the performance equation. Tau is equal to Ca0 integral 0 to xa dxa by minus Ra. So here tau even I can write as it is nothing but ratio of volume by volumetric flow rate. So now what I can write is volume by volumetric flow rate is equal to Ca0 integral 0 to xa dxa by, since it is a first order reaction, K into Ca I will write. Ca I can write as Ca0 into 1 minus xa. Okay, so Ca0 will get cancelled out. Then you will get K into V into volumetric flow rate is equal to integral term of dxa by 1 minus xa is minus ln of 1 minus xa. That is the integral term. Now we should apply the limits 0 to 0.9 conversion. So if I substitute all the values, rate constant value is 0.002 into V divided by, so volumetric flow rate and rate constant both are same. Okay, 0.002 volumetric flow rate is equal to minus ln of 1 minus 0.9. If we solve, then we will get the volume 2.2 meter cube, 2.2 meter cube. Now we need to do the calculation for CSTR also, and we need to justify whether the volume occupied will be more, is it in PFR or CSTR. So now if I do for CSTR, the performance equation is V by volumetric flow rate is equal to Ca0 xa by minus Ra. This implies volume is, we don't know, volume by volumetric flow rate 0.002 is equal to initial concentration value is given as 1 into constant conversion is 0.9, divided by K into Ca. K is 0.002, Ca0 into 1 minus xa. 1 minus xa is 0.9. So Ca0 here also Ca0 will be there, both will get cancelled out. Then you will get volume. How much? 9 meter cube. So the justification is volume of CSTR is more than the PFR for the same for 90% conversion.
Therefore, PFR is better than CSTR.
90